we will continue the drip irrigation components with the mains and submains. For mains and submains, PVC pipes are mostly used. High density polyethylene is also sometimes used, but it is little costly. The PVC pipes are available in the market with the external diameters of 40 millimeter, 50, 63, 75, like that. The strength of the pipe is also that is used normally varies from 0.4 megapascals to 0.6 megapascals. As far as India is concerned, still for strength, the pascals unit is not very much used. In India, conventionally still kg per centimeter squared is used. Though Government of India discourages the using of this kind of unit, people are using it. So we may need to know the equivalence for these kinds of units also. So 1 KSC or 1 kg per centimeter squared is equivalent to 0.1 megapascals. And it is equal to 10 meters of water column. These are all some of the PVC fittings. Those are commonly used in drip irrigation. This is called female thread adapter. You see here, this is called female thread adapter, FTA, and this is called male thread adapter. So these two components are used to connect PVC pipes with GI pipes. If GI pipe has an external thread at one end, then one can use this female thread adapter to fit into that GI pipe, and from this side onwards, one can use adhesive to connect PVC pipes. Similarly, if our GI pipe has an internal thread, then with this component we can connect PVC pipes. So when this is connected, from this side onwards we can connect PVC pipes by using adhesives. This is a T. The use of T is obvious when one wants to divide a flow into two branches, then one can use it. This is equal T. All sides are on all sides the diameter is the same, and this is a reducer T. This is a main pipe, and if you take a smaller takeoff, then one can have a smaller section. So for in different sizes, these kinds of fittings are available. And this is a reducer. So when one wants to, along the way, when one wants to reduce the size of the pipe from larger diameter to smaller diameter, one can use this reducer component. And this is called union. This union is available both in GI, galvanized iron, and also in PVC. So on both the sides, you will have threads. So wherever we feel like some kinds of repair works are to be done, wherever the pipe is looped, this kind of union connection is essential. So the use of union, I will explain in the next slide with an example, so that you will be able to understand better the use of union. And this is called saddle clamp. This is also used for taking off. Is something similar to T. From a larger diameter pipe, one can take off smaller diameter pipes. But there we have to cut the pipe and join it. But here you do not need to cut the pipe at all. Just on the pipe itself, one can put a hole and fit it. And the same saddle clamp is used for fitting pressure gauges also in the pipes. And this is a bend. It's a short bend. Long bends are also there with a curve. And this is a PVC end block. At the end of the pipe, you can using adhesive, you can close the end of the pipes. And this is a threaded nipple. This component is also available both in GI as well as in PVC. Um, and flush valve. Flush valve also already we have seen flush valve. It is fitted at the end of the submains. See here. This is a filter. Filter is connected from the delivery of a pump. For connecting a filter with the backwash facility, with a backwash facility, how many components are needed? You see here. First, during normal filtering process, water goes this way and gets filtered and comes down like this. During this process, this valve will be closed. This valve also will be closed, and this valve will be opened, and water goes this way and comes down, and it goes to the field. In case of let us say one wants to wash the filter, during that process, what should be done is this valve should be closed. Then water from pump would come and go through this way, and this valve will be opened, and on this side also you should have one more valve, and that should be closed, so that water goes this way. And it is called backwash process because the water flow in the filter is reversed, and water goes this way and comes here. Because this valve is closed, water will come and pass through this, and this valve will be opened, and the wash water will come out like this. So this is the process of backwash process. So in order to have this kind of a system, you see how many small components are needed. See here on this side you have one union, okay, threaded connection, one union, and then a threaded nipple, then a T, then a threaded nipple, then a union. Then from here to here, to connect this valve and union, you need one more threaded nipple, and again on this side a threaded nipple and a T and a threaded nipple and a pipe section here with a valve. Similarly on this side, okay, a long piece of pipe with a bend and a long piece of pipe, then an union, and maybe this may be a threaded nipple and a piece of pipe. So many small components have to be connected. Only then we will be able to achieve what we intended. So look here, union. This union, if one wants to, if some kind of a repair occurs at for this valve or at this filter, then one has to open it. So if everything is connected without an union here, it cannot be opened. Even fitting becomes difficult. So if you have a union here, then union, if you unscrew the union, then part on this side and part on this side can be disassembled. Same way here also, same thing. So wherever the pipe is looped, something like this, you need to have a union. See here also there is a union. If somebody wants to do some kind of a repair at the pump side, then this has to be disconnected. So you need a union. So this pipe submain lateral connections. How a submain is connected to lateral and all. This is to show that PVC pipes should not be laid over ground like this. If the PVC pipes are laid over ground like this, then there is possibility that it will get affected. It will get affected by sunlight. The ultraviolet radiations will affect the PVC pipes, and these pipes will become easily brittle. So for mains and submains, I said already, sometimes high density polyethylene pipes are also used. They are very costly, and if they are used, then they can be laid over ground. High density polyethylene pipes are capable of withstanding ultraviolet radiations from sunlight. See here, the mains and submains, how they are laid underground. These are all submains and mains. They are laid underground. Next, we will see laterals. Laterals are flexible pipes. They are made of low density polyethylene. Sometimes you will find LLDPE. They are called linear low density polyethylene. They can be laid over ground, and they are available in outer diameters of 8 millimeter, 12 millimeter, 16 millimeter, and 20 millimeter, and things like that. As far as India is concerned, this 8 millimeter pipe and 20 millimeter pipes are rarely available. They are not very much available. But in India, only 12 millimeter and 60 millimeter pipes are available in the market. See here how a lateral pipe is connected with a submain. First a hole is drilled. And a lateral washer. A lateral washer is placed inside this hole. Then a lateral start, or sometimes it is called a barb adapter, something like that. Each company will call this component with its own name. I call this as a lateral start. After this washer is put here, then this can be inserted here by using just by hand pressure, or by using a wooden hammer also it can be inserted here. And over this lateral is inserted. At the end of the lateral, it is bent like this, and the lateral is closed, something like this. So if you look here, after fitting the lateral start in the submain pipe, how does it appear? Okay, this is a drilling tool normally used, and this is the drill guide, and this is placed over the drill guide is placed over the pipe, and drilling is made with through this hole, so that you get perpendicular holes. So that is the objective. So these are all the fittings used for connecting laterals. They are made of high density polyethylene. Lateral is made of low density polyethylene, but the fittings those are used to connect the laterals are made up of high density polyethylene. These are all the fittings. By looking at the shapes of the fittings themselves, one will be able to understand for what kind of purpose this is used. This is a lateral bend, and this is a lateral start. It is to connect lateral to the submain. This is a lateral connector. Two laterals can be connected, and this is a lateral T. Lateral can be divided into two. If one wants to take off one more lateral from a lateral, then one can use lateral T. And lateral reducer. If one uses on one side 16 mm, then one wants to reduce 16 mm lateral to 12 mm, then one can use this kind of lateral reducers. Lateral end block, already I said, this is this component. For closing the lateral at the end, this lateral end block is used. And microtube connector. Microtubes are very small tubes. Their diameters are less than the lateral diameters. Normally 4 mm diameter and 6 mm diameter micro tubes are available in the market. Uh, one can take off from the lateral the small micro tubes using this micro tube connector, and this a component called goof plug. The usefulness of this goof plug is that if unwanted holes are made on the lateral, then those holes can be plugged with the goof plug. But this goof plug are not 100% leak proof. Uh, to some extent, it will arrest the leak. Uh, this is about lateral fittings. Next is emitters or drippers. This is a very important component. Emitters or drippers. The function of the dripper is that through which water comes out of the pipe network. What does a dripper do is it dissipates the pressure of the water inside the pipe, and when water comes out of the dripper, it loses all its pressure, and finally when it comes out after losing all the pressure, water comes out as droplets. The drippers are specified using liters per hour discharge rate. If it is said as 2 liters per hour or 4 liters per hour, it should be understood that doesn't mean that all the time the dripper will discharge 4 liters per hour. Whatever be the pressure, don't think that you will get 4 liters per hour. 4 liters per hour implies that the pressure head at 10 meter. The pressure head at 10 meter only it will deliver 4 lph. If the pressure head gets reduced, then the discharge will also get reduced. If the pressure gets increased, then you will have a more discharge than 4 lph. This is the dripper discharge equation. This is much similar to the sprinkler discharge equation we studied during sprinkler subject. Q is equal to K into H power X. Q is the discharge rate from the dripper, and K is the discharge coefficient, and H is the pressure head, and X is called the flow exponent. For sprinklers, we studied that the flow exponent will always be 0.5. As far as the dripper is concerned, it is not constant. It varies. It varies depending on the type of dripper. It varies from 0 to 1. Lower values of flow exponent is very good. Let us assume that x is 0. X is 0. What will happen? Q will become equal to discharge coefficient. So you will get a constant discharge irrespective of the pressure head in the pipe. You will get a constant discharge. So this is highly desirable. Along the lateral, the pressure will vary. Even if pressure varies, if the dripper is able to deliver a constant discharge, then it is good. So lower flow exponent values are very good, and x value varies to goes even to 1. So these larger values are not very good in terms of pressure, in terms of discharge variation. So how can we find the dripper constants like K and X value? Let us assume that discharge rate of dripper is given as 4 liters per hour at 10 meters of head, and flow exponent of dripper for one dripper, let us assume that it is given as 0.5. So for this small problem, we can find out what will be the K value. So it is 4 lph. K is not known. It is 4 lph at 10 meters of head. The dripper type is called orifice type, and for orifice type, it is the X value is 0.5. You recall that orifice means just a hole. It is much similar to your sprinkler. For sprinkler also X value is all the time it is 0.5. So K is equal to, for this problem, K is equal to 1.265 liters per hour per meter power 0.5. So meters is pressure head, and here it is 0.5. So it comes like this. So if your x value is something different, say 0.8 or 0.4, then these units should be substituted differently here. So that should be kept in mind. Sometimes the manufacturers provide the pressure head versus discharge relationship as a curve. If this kind of curves are made available to us, then from this also one will be able to find out k value and x value. So how it can be done? Look here. You take any 2 point. You take any 2 point. For any 2 point, one will be able to get 1q and q1 and h1. For next point, you will get q2 and h2. So already we know that for a dripper, k and x are constant. So for 1 point, if you substitute, you will get q1 is equal to k into h1 power x. And for the next point, q2 will be equal to k into h2 power x. So in this case, q1, q2 and h1, h2 are known, and k and x constants are unknowns. So we have two simultaneous equations and two unknowns. So if we solve these two equations, then one will be able to find out k and x value. A small problem that has been given in my manual, and you can look into that problem and practice it for examination. So next concept is manufacturing variation. You know that in any industrial process, no two components can be manufactured exactly, because the manufacturing process itself is variable. Let us say one makes two drippers of 4 liters per hour discharge rate. If that dripper is examined at a 10-meter pressure head, it will not give exactly 4 liters per hour. It may give 4.1 or 4.05 or 4.01 like that. Let us assume that it gives 4.1. And the next dripper gives 3.8 liters per hour at 10 meters pressure. So this is how things will vary. So you should keep in your mind that if it is said that 4 liters per hour at 10 meters pressure head, on an average you will get 4 liters per hour. But individual drippers, if you examine each dripper by dripper, you will find that it will vary. So based on manufacturing variation, how the drippers are classified is, if you have the manufacturing variation is less than 5%, it is classified under excellent. And if it is 5 to 7%, it is classified as average. And if it is 7 to 11%, it is classified as marginal, and 11 to 15, it is poor, and greater than 15, manufacturing variation is unacceptable. Normally nowadays in India, in excellent category, we get drippers. And we will now see types of drippers. The drippers are divided into two kinds of drippers called online drippers and inline drippers. This classification is based on the way in which drippers are attached to lateral. In case of online drippers, their hole can be punched, and the dripper is a separate component, and lateral is another component. Hole can be made with a drill bit, and one can insert a online dripper. The advantage of an online dripper is it can be opened for cleaning. And the disadvantage is after some time you will get leakage at the points of connection. And for tree crops, online drippers are very much used nowadays. Even for tree crops, this is not very much used. But for drippers, for trees, it is very much recommended. And sometimes when you have a tree like a mango tree or a coconut tree and all, one may need to apply water at different points. So in that case, what is done is one can take off from the lateral. Small micro tubes can be taken out, and micro tube connector can be connected with the lateral after making a hole inside the lateral, and micro tube can be connected, and at the end of the micro tube drippers can be connected. So this is how online drippers are used. It can either be placed directly on the lateral, or it can also be connected with a micro tube, and at the end of the micro tube one can have drippers. Next classification is inline drippers. Inline drippers are the drippers are integral part of the laterals. While manufacturing itself, they are placed inside the lateral, and they are purchased. So, if one purchases a lateral with inline drippers, one cannot change the spacing between the drippers, or the dripper discharge rate and all have to be priorly fixed, and it should be purchased. Nowadays this is very much used, and it has a lot of advantages, and it does not have leak problem and all. This can be the laterals can be rolled very easily and placed at the end of the fields when we do interculture operations and all. These kinds of inline laterals are very much used for row field crops and small tree crops like citrus and drumstick, and like that. Even nowadays, these kind of inline laterals are used for tree crops also, because of its advantages over online drippers. In these kind of drippers, this is the flow passage. This is a cut section. You see, when water passes through these narrow passages, they are designed in such a way that turbulence and rotation of flow occurs in this narrow passage, and because of that pressure dissipation occurs, and because of this process itself, there is a kind of a self-cleaning ability. So to some extent, the dirts automatically get cleared with these kind of drippers. Inline drippers are, in case of flexible pipes, there are also kinds of flexible pipes used as laterals. On the flexible pipe wall, the drippers are placed, and these are less costlier than the thick pipe inline laterals. Lastly, pressure compensating drippers. Whatever be the type of dripper, at the exit of the dripper, if a flexible rubber diaphragm is provided, then you can say that this is a pressure compensating dripper. Why this flexible diaphragm is provided is this flexible diaphragm adjusts the diameter of the flow passage. It adjusts the diameter of the flow passage in such a way that you get a constant outflow. All the time you get a constant outflow. So already I said its X value ranges from, for pressure compensating drippers, it varies from 0.0 to 0.2. Ideally, it should have zero flow exponent, but it is not possible to manufacture to such an extent with zero exponent X value, but it will go near to 0.2. So when in hilly areas, when laterals are designed, when you have lots of undulations, more ups and downs, then these kind of pressure compensating drippers are used. But unless it is necessary, it is better not to go for pressure compensating drippers, because all these drippers are exposed to sunlight. So since they are exposed to sunlight, you might be knowing that because of the solar radiation, this diaphragms, because they are made of rubber, it loses its flexibility within a year or two. So the pressure compensating drippers would work very well for a few years. Then after some time, after the flexibility of the diaphragm is lost, then it will not function very well. And so unless it is needed, better not to go for pressure compensating drippers, and they are also costly. Lastly, micro sprinklers. Already I said the micro sprinklers, though it is called as sprinklers, micro sprinklers are most of the time studied under the drip irrigation subject only. And micro sprinklers are small, very small sprinklers. They with diameter of 2 meters to 8 meters, and they have a discharge between 20 liters per hour to 50 liters per hour. Mostly they are used for tree crops, and their X value, flow exponent value, is constant all the time. It is 0.5. So because it is similar to your sprinklers, it has just a hole. It has just a hole through which water comes out, and water gets sprayed because of some kind of a mechanism at the exit. There are different kinds of hundreds of kinds of micro sprinklers can be seen. Uh, so this is about micro sprinklers. And lastly, we will see in this class about subsurface drip irrigation. What actually is subsurface drip irrigation? In subsurface drip irrigation, laterals are laid below, underground, below 15 centimeters to 30 centimeters. And there can be where it is laid at lower depths like 15 centimeter is in case of sandy soils, and in case of salty soils they are not laid uh, too deep like 30 or even beyond that. They are laid at a shallow depth, because in sandy soils you know that the size of the pore is larger, and you will not have a good capillary rise. If you do not have a capillary rise, the water will not rise up to the root zone. So in case of sandy soils and all, the subsurface drip irrigation is buried under less depth, like something like 15 centimeter, even less than that, 10 centimeter also sometimes, at which it is buried. In case of salty lands also, if you are burying the laterals at a deeper depths, what will happen is the salt deposits that would get formed inside in the root zone. In the root zone, it will get formed. So that will affect the metabolism. So that is the reason why for salty lands also the laterals are laid at shallower depths. So this is a diagram you can see in which a subsurface lateral is laid. You are not able to see any lateral over ground, but you see that how the field gets wetted. And the other features with regard to subsurface drip irrigation is normally, previously when subsurface drip irrigation was used, thick tubes like surface drip irrigation only was used. Later on, people found that with thicker tubes, it is good, but retrieving the pipe after it is placed underground, it becomes difficult. So why to waste unnecessarily thicker tube? So people thought why to use thicker tube. And nowadays people use for subsurface drip irrigation only thinner tubes, very thin tubes of wall diameter 0.15 millimeter to 0.6 millimeters. It is because retrieving the pipes becomes very difficult. So after a few years are over, something like 5 years or sometimes 10 years even, then they are left underground, or they are taken bit by bit. So that is the reason why in subsurface drip irrigation thinner tubes are used. In subsurface drip irrigation, one more difficulty is the roots intrude into the drippers, because the the plant also has some amount of intelligence, and it knows water comes from where. So it finds that water comes from drippers. So when at times when you do not give sufficient water, or when irrigation during the process of irrigation scheduling, you irrigate after a larger gap, what it would do is the drippers would go and intrude into the drippers. So in order to overcome this issue, what manufacturers do is they impregnate with a chemical called trifluorine. These chemicals will be constantly emitting from the drippers, and this will, if root comes and touches the dripper, then that will get burnt. But it's very bad idea. Still people do it, but um, sometimes what farmers are recommended, it's not recommended. What company people do is they recommend to inject the chemical trifluorine, like hydrochloric acid. Trifluorine is also injected uh, to avoid root intrusion, but it's a very bad idea. And trifluorine is the one of the deadliest chemical in US and Europe and all. It is banned chemical, and if at all in some states in USA, if it is used, only once in a year one farmer can use, because if trifluorine goes and reaches the groundwater and all, then lots of health issues would arise. And recently, one company called Rainbird, they have invented a dripper, and they have provided a copper small sheet at the exit of the dripper. And what does this copper shield do is, when roots come and tries to go into the dripper, when it hits on the copper shield, then it gets burnt. So that is one of the newest technology that is used for preventing root intrusion. And this is a typical layout for subsurface drip irrigation. See here, this is a submain. This is a submain, and from submain the laterals are taken and they are laid underground. They are laid underground. At the end of the laterals, if you see, in case of surface laterals, it is just bent and closed. But in case of subsurface laterals, if you see, all the laterals are connected by again a PVC pipe, and at the end of the PVC pipe, you give a you fit a pressure gauge, and also you fit a pressure a pressure relief valve and air valve. Okay, pressure relief valve and air valve. So why pressure relief valve is placed? It is obvious, because since it is underground, there may be possibilities of total clogging. In case of a total clogging, if pressure gets increased beyond a limit, then there may be a bigger breakage. So in order to avoid the breakage, pressure relief valves are provided. And vacuum relief valves, air valves in last class, how it functions and all I discussed. So if air valves are not provided, then there is possibility of the soil particles getting sucked into the laterals. So in order to avoid that, one needs to provide vacuum relief valves or air valves. And see here, on one side of the submain, on the submain also one valve is provided. On the other end also another valve is provided. So at least one valve should be provided. uh, I told in last class itself, even four valves, one here on one this side and one this side and another on this side also is recommended. This will prevent soil particles getting sucked into the laterals. And what else? Pressure gauge is very important. If you have a pressure gauge, then one will be able to find out whether it is totally blocked underground, or if the pressure gauge value falls down, also one can understand that some kind of a total breakage has occurred. Sometimes rats cut open the laterals, and because of that there may be lots of leakage, and during that time we will find that the pressure value gets dropped down to a larger extent. In that case, one will be able to find out some kind of a problem has arisen. We will see now advantages of subsurface drip irrigation. As it is obvious that since the wetting occurs from the bottom, from down towards up, there is a evaporation loss is minimum. At least 10% less water is saved. At least 10%. And with a given amount of water, if you use surface drip irrigation and also subsurface drip irrigation, with the subsurface drip irrigation with the given water, we will have a bigger wetted volume. So bigger wetted volume is very good, because bigger wetted volume implies you can have a bigger volume of soil. Bigger volume of soil, you will have a bigger root zone, and bigger root zone will be able to take nutrients from a larger area, and so the crop will also be better, and also it's what you call the drought withstanding ability will also be very good. And since the laterals are underground, mechanical harvesting is possible nowadays. With sugarcane crop and all, getting labor for harvesting sugarcane is very costly. And because of this fact, farmers nowadays opt for subsurface drip irrigation, because mechanical harvesting is easily possible, and also one can do weeding and other processes with machines. So because of this advantage, for sugarcane and all, it is picking up very well. And last advantage is the low quality waters like sewage water. Sewage water can be used with subsurface drip irrigation, because you don't need to see the water at all, because it is applied underground. So with low quality waters, the application of subsurface drip irrigation is very much recommended. Now we will see the disadvantages. As far as disadvantage is concerned, the first disadvantage is there is possibility of back pressure getting developed around the drippers, because when water comes out of the dripper, and that water should move out of the dripper. If your soil does not have the capability to move the water from the zone around the dripper towards the periphery, then there is possibility of pressure getting developed, and that will cause back pressure, and it will affect water coming out of the dripper. So this is very much felt in the clay areas, and it is also very much felt when one uses non-pressure compensating drippers for subsurface drip irrigation. So if you make use of pressure compensating drippers, then this problem can be overcome. And in case of soils which are non-clayey in nature, with less clay, like loamy soils and sandy soils and all, this back pressure problem does not exist at all. And the next problem is obviously soil particles get sucked into the drippers. So if one provides good air valves, at least 1 to 4 air valves, then that problem could also be solved well. And another disadvantage is that damage to laterals during mechanical harvesting is possible. If the depth of lateral laid is low, then there is possibility of damage to laterals. And the other disadvantages include obvious disadvantages. Rodents like rats and squirrels can damage the laterals, and already we saw the root intrusion problem is there. And finally, the last disadvantage is that since all laterals are underground, if it is not functioning, or if it is functioning, cannot be seen very easily. It is known very late, and only after the crop shows symptoms of failure only, after crop failure only, we are able to find out there is some kind of a difficulty in subsurface drip irrigation. So this disadvantage. And attending failures is very costly, because everything is underground. opening up and finding where the difficulty is. It is also costly, and with high salty water, if it has ion, bicarbonates, and calcium salts, calcium magnesium salts, and all, the risk of clogging is very, very high. So, in such kind of situations, if subsurface drip irrigation is used, one should opt for preventive maintenance, and injection of acid with all irrigations can also be done. So, a better management practice should be adopted when subsurface drip irrigation is used with saline water. So, with that, I conclude this class. Thank you.